Hello, everyone. So good to see you all today. Before we jump in, I need audience participation. I have a few questions for you. How many people have had an opportunity to play around with machine learning? And I don't mean sending prompts to ChatGPT, that doesn't count. I mean training your own custom machine learning models. Okay, cool, many of you. Just curious, what kind of model did you train? Okay, and I saw some people over here. Care to share what type of models you trained? Audience participation. Oh, wow, that sounds cool. What about you? Okay, nice. Nice. Okay, some advanced use cases I hear. And I'm going to ask you a question. You don't have to answer out loud, just think to yourself. Did you consider bias and ethics? Okay, some people just automatically saying no. Okay, how many people use machine learning on your day-to-day job? No one. Not even ChatGPT to help you write your code, double check your code. Okay, okay. I expect if I ask the same question this time next year, everyone's hands will go up. Because of ChatGPT, it is just a great tool to help developer productivity. Okay, my last question. How many people want to play around with machine learning? Okay, if you stick with me until the end, I have a special treat for you. Okay, now I'm going to pose 4 different scenarios to you, and I want you to think to yourself, you don't have to answer out loud, is this scenario ethical or not? Okay, the first scenario, a man is not granted parole because a machine learning model says he will be a repeat offender. Is that ethical? The next scenario, a woman's life is saved because machine learning found breast cancer undetectable by a doctor. Ethical or not? The third scenario, more than 1/3 of A-level results, basically grades, downgraded in the UK by a machine learning model. Is that ethical? And the last one, women aren't recruited by Amazon because a machine learning model learned that women don't make great engineers. Ethical or not? As we see today, machine learning has moved from the research lab to large enterprises. Questions around risk and ethics become even more critical. And by the way, all of the 4 scenarios that I shared with you actually happened. So in the US, there's a system called Compass that judges use to help determine if someone is going to be a repeat offender. That person may not get parole. Models can actually detect breast cancer long before a doctor can make the diagnosis. And to me, that is just amazing. And the third scenario in the UK, grades were downgraded from maybe an A to a B to a C based on what a machine learning model said. And of course, parents were in an uproar. And lastly, Amazon did have a recruiting tool that actually downgraded resumes sent in by women. All of this is real. Now, did the creators of these systems consider bias and ethics before moving these systems to production? I would say 3 out of 4, probably not. But after you leave this talk today, you'll understand how to integrate risk and ethics into your AI-powered systems. So quickly, I am going to tell you a little bit about myself. Hi, everyone. My name is Kehsa Williams. I've been in tech for 28 years. I'm actually ready to retire. I feel like I should be retiring right now. And I like to share my journey based on my technology path. So I started coding when I was in high school. I started with the basic programming language. Anyone in here code basic? All right, it's my people. I started with basic. My first job out of college, I used what I call the precursor to .NET, so ASP, active server pages, ActiveX controls, Phoebe script, running production on a Microsoft Access database. That was me. And then there was Java. I literally remember the day that the Java programming language was released, and I researched it, and I said to myself, this language is going to take over the world. This is where I need to take my career. And that's what I did. I think it was the best career choice I've made. Java has been a really strong foundation. But then I was introduced to the cloud and AWS and Amazon Web Services. And that same level of excitement that I felt for Java, I felt it for the cloud and AWS. I said, oh my goodness, the cloud is going to revolutionize the way we build systems, the way we support systems. It's going to allow rapid innovation. This is where you need to take your career. Then in 2017, because of my exposure to the cloud, I started learning about AI and machine learning in the cloud. And now, what's next for me? I don't know. I don't know what that new exciting technology is for me. And like I said, I'm ready to retire, so I may just end up with AI and machine learning. Currently, I work for a company called Slalom. We are a global consulting firm. We help organizations build better software. I lead a team called the AWS Cloud Residency, which is an career accelerator for cloud engineers. We help our customers migrate to the cloud and modernize their applications. I have a few distinctions from AWS, Machine Learning Hero, Ambassador, and Alexa Champion. That is me. Now, what is AI? Based on the number of hands that went up during my audience participation, most of you here already know what AI is all about. It's the simulation of human intelligence by machines. And machine learning is just a subset of that applies mathematics to large data sets, finding trends and patterns, and storing those trends and patterns in a model to help you make business decisions. But the challenges we are facing today with AI, it's really all around bias and ethics. So should a student be able to use ChatGPT to help them with their homework? You look like a student. Do you use ChatGPT to help you with your homework? Is that ethical? Can I put my name as the author of a blog if the entire blog was AI generated? Is that ethical? And then with any machine learning system, are the recommendations fair and unbiased? So when I began my machine learning journey way back in 2017, I was literally blown away by how pervasive machine learning was. It really, at that time, had impacted my life in ways that I couldn't even imagine. Does anyone here use Netflix? Yes. So Netflix uses machine learning to recommend movies. Amazon uses it to recommend products. There are risk assessment systems. We talked about the COMPAS system used by judges in the United States to determine if someone is going to be a repeat offender. Even banks use it to determine if you're going to default on the loan that you're applying for. Department stores and fast food chains like Starbucks use it to help them better understand their customers so they can use targeted marketing campaigns. It's also used for things like anomaly detection, credit card fraud, login attempts, and also personalization. Machine learning models can learn your behavior and try to predict what you will do next. Facial recognition, this is a big one. This is where you can identify people and objects in images. So on my international flight over here, Delta Airlines scanned my face before allowing me to board the plane. Do you think that's ethical? I don't ever remember giving my permission for them to take my photo, store it, and probably share it with government agencies. And lastly, chatbots. I'm sure you all have interacted with chatbots. Whenever you are online and you have a customer support question, the first person that you'll talk to is a chatbot. And I always type agent or representative because I'm trying to get to a real person. So how do machine learning systems work? What we're going to talk about now is just supervised learning. It's a very simple, basic use case using labeled data. And so the machine studies the data, finds the trends and patterns between the inputs and the outputs, and it learns how to map those inputs and outputs, and it stores it in this model, this mathematical model. And when you think about building AI systems, the model is the actual artifact that you're producing. So when you think about you're building an app, with machine learning systems, you're building the model, and we simply call it the model. And once you have this model, you can send an input that it's never seen before. It learned by finding the trends and patterns, and it maps that to an output. So output could be, will this person be a repeat offender? Yes or no? Should this person's final grade be a 95 or an 80? Or what is this an image of? So that's machine learning at a high level. I know this is our developers conference, so I have a lot of software developers and engineers in the room. We all know how traditional software works. We write the code, we tell the machine what to do, and the software spits out the data and we use it. We use languages like Java, my favorite of course, C#, JavaScript, and Python. But machine learning is a bit different. Think of it in the reverse. So we give the machine the data, it writes its own code to solve the problem, and I think this process is really cool because the machine can produce output without us explicitly programming it and telling it what to do. The process to develop a machine learning system when you're using supervised learning, it's a pretty standard process. So first you have your training data. And we can take the case of, let's say, predicting the cost of homes in California. Remember I mentioned the label data. So we'll have, let's just say, a spreadsheet of multiple rows that has the cost of a home and then all of the factors that can influence that cost, like the location, age, etc. So you take that training data and you feed it to a learning algorithm, and it goes through this training process that produces this model. Then we have the input. So this time we're not passing in the cost of the home because that's what we want the machine to predict. We'll only pass in the factors that influence the cost, like the location, age, etc. And so now the machine, using the model, spits out what it thinks the cost of the home will be. So that's the prediction. And so when you have this prediction, just remember at the end of the day, we're still building software. So garbage in, garbage out. You have this prediction, and there are questions. Can I trust this prediction? How can I find errors? And why is the cost of the home so expensive? That just doesn't seem right. So throughout this process, there are questions we can ask around ethics and bias and explainability to help answer all of these questions. So that's where we talk about ethical AI. And of course, I think I use ChatGPT several times a day for what I'm working on. And so I had fun asking ChatGPT about ethical AI. So I'm asking AI about AI, and it's amazing that this is the world that we live in today. And so the response from ChatGPT was pretty spot on once I read it. I saw terms like fairness, transparency, responsibility, human rights, not perpetuating bias, considering the potential consequences, mitigating negative impacts, all of the things that we consider when we think about ethical AI and ethical machine learning. So that is the textbook answer when we think about ethical AI. But for me, this really boils down to one thing. I can build it, but should I? And if I do, what guardrails are in place to protect the person that is the subject of the AI? We looked back and we talked about those 4 use cases at the beginning. Those have major impact on the lives of people. And I can be honest with you. Building a machine learning system that you actually trust with the lives of others is a huge undertaking. So I've been working with machine learning since 2017. I've built predictive policing systems. I've deployed machine learning models on edge devices. I've built systems to detect when my kids are stealing soda out of the refrigerator. My kids really enjoy having a mom in tech because they are often my guinea pigs. And so with all of that, I've only still scratched the surface. I learn something new every day. And now, even with the release of generative AI and ChatGPT, it is just mind-blowing. And ethics still continues to crop up as a developer of machine learning systems. So when we think about bias, and I keep mentioning bias and ethics as a huge problem in AI right now, bias goes against a code of ethics. So we saw that systems can identify people using facial recognition. They can also determine demographic attributes about people. And they can also determine preferences, i.e., predict your next step or your likely future behavior. And can you imagine if a machine predicts incorrectly? And that happens quite often. Just the impacts. You want those recommendations to be fair. Now, to a very important part. How does bias surface? Most people think bias is all about the data, but it's not. So bias can be found in your training data, and we'll talk more about that in detail. But the machine learning algorithm, that learning algorithm that you select, can also be biased. And then once a model is in production, that model can drift, and that leads to biased decisions. Did anyone hear about this story? What happened in San Francisco with facial recognition? Well, one day when I was reading the news and I saw that San Francisco banned facial recognition technology, I was very disheartened, very sad, as a person that pursues and loves emerging technology. And I just thought to myself, like, the technology is not the problem. And so basically what happened in San Francisco, they banned facial recognition in 2019, and it was the first major city in the US to do so because the facial recognition system was not working properly. And so it basically it tends to misidentify people with darker skin. And to immediately rectify the situation, they just outright banned the technology. And that's what they had to do. But like I said, the technology is not the problem. Like, we are the problem. How we've implemented the system, how we've designed the system, how we've developed the system, our lack of testing the system, that's the problem. And until we can get that right and figure out that piece, I expect to see just more widespread bans of just machine learning in general. And the issue with that system, they built it, but it didn't reflect the environment that the system was running in. And we'll talk more about that. So let's look at just a quick example of when I say bias, what it really means. Okay, so let's say we are training a system to help us identify or classify flowers. And this is our training data. What do y'all think will happen? Does that data have a lot of diversity? Do we only have 2 types of flowers in the world? We have hundreds and hundreds, right? Okay, so let's say I've trained this system and I pass in a picture of a sunflower. It would identify that correctly, right? What if I pass in a picture of a rose? Maybe, maybe not. What if I pass in a picture of a tulip? What in the world happens? Like the system explodes. It's like a catastrophe. Everything melts down. It's the end of the world. So in this case, we have trained a machine learning model that is skewed or biased towards sunflowers. Almost everything would be a sunflower. And this is just a small example of a much bigger problem when we deal with machine learning. So let's say we have a recruiting tool like Amazon, and this is the data that we're training the model on. And this is exactly what happened in their case. They looked back 10 years and they pulled all of the resumes of people that had applied to work at Amazon, and this is what the training data looked like. And when you look at this example, who do you think the model would prefer? That would make a great software engineer. Yep. Definitely not women. Women don't make great software engineers. And so Amazon quickly had to pull that. Once it was found that it was biased, they quickly removed using that. If this fly does not leave me alone, they quickly removed that Amazon recruiting tool. Again, and I'm going to say this a million times, it's important for the model to be trained on data that reflects the environment where you're going to use that model. Okay, so now let's talk about the pre-machine learning world. So this is a world where humans made hiring, advertising, lending, criminal sentencing decisions, And in the US, those decisions are governed by federal, state, and local laws. So those decision-making processes are regulated and they're evaluated for fairness, transparency, and equity. That's the normal world. So it's against the law to discriminate because of age, gender, marital status, being pregnant, being on maternity leave, your race, which includes your color, nationality, ethnic origin, your religion, all of that. You cannot discriminate against someone because of that. But now, in this machine learning world, machines heavily influence all of the decisions that I just talked about. And in the US, a thing called IP, or intellectual property, protects the inputs to algorithmic decision making because it's seen as a trade secret. So companies in the US don't have to share this information. And so I say discrimination wasn't allowed before machines, and it shouldn't be allowed after machines. It's a lot of things for us to think about as developers. Now, if you've been on the receiving end of an unfair or biased decision, you know that it can unfairly allocate opportunities or resources or information. It can infringe on civil liberties. It can even pose a detriment to the safety of individuals. We think back to the facial recognition software that was banned in San Francisco. It misidentified someone as a criminal that really wasn't that criminal. It can fail to provide the same quality of service to one person as another. For example, you're trying to get a home loan. For whatever reason, the machine learning model says you are going to default on that loan. You can't buy your new home. It can also negatively impact a person's well-being, mental health. Mental health is a big issue in the United States. And then just internal conflicts inside of companies around ethics. So for example, Google employees have often protested the systems being developed because they were unfair and unethical. Now, I mentioned to you before, everyone thinks bias is all about data, but it's not. Bias can show up in many places. So first, it can show up in your people, and we'll talk more about that. It can show up in your strategy. It can show up in your data, that's a given. It can show up in your algorithm, in the model, and the action you take based on the predictions. So now let's dig a bit deeper in each one of these. So what do people do? How can bias show up in your people? Well, we build the machine learning systems. We have certain perspectives about life, what's right, what's wrong. And oftentimes, people have implicit biases, biases that they're not even aware of. So when I think back on the facial recognition system that we talked about that was banned in San Francisco, the developers developing that solution probably wasn't a diverse team, and so they created the data set that looked like them. And that's just how it is. And that's why you need teams that are diverse to bring in the different perspectives, to highlight things like that. And so when you're thinking about ways that bias can show up in your people, there are questions that you need to consider. Is what I just mentioned, is this team diverse enough to represent minority viewpoints? Does the person have implicit biases that could transfer to the system without them even knowing? Next, bias can show up in your machine learning AI strategy. So this is where you explore your current business processes, you try to identify where machine learning adds value, and you define those inputs and outputs. And right now, a lot of organizations, because of generative AI, machine learning, there's just a lot of hype. Everyone wants to try to force fit and make every problem solvable by machine learning. And that is absolutely the wrong approach. That is not the case. Machine learning does not solve every problem. So when you think about your strategy, there are risk and ethics questions you can ask. One, how could your system negatively impact people? I mean, it's a very simple question it's a very simple question that you can ask as you're thinking about building these machine learning systems. And then think about the prediction error rate. And so not every machine learning system is going to be perfect. You will probably never have 100% accuracy. But you have to figure out what threshold you're willing to accept. So for example, you'll have false negatives, false positives. What's the threshold you're willing to accept, and determine that upfront. And then will you need to explain the inputs, influence, and how they influence the outputs? So for example, you apply for a home loan, you get turned down. The answer can't be, well, the model said no. People will want to know why they got turned down, and you'll need to, and we'll talk about explainable AI, but you'll need that component where you can explain to people why. And then your data. This is the most common form that everyone is familiar with, bias and data. And so you have your raw data, you process it, you format it, you prepare it for machine learning algorithms, you analyze and understand that data, trying to find anomalies, outliers, things that could actually impact the prediction capabilities, and you remove those things. And then you pair engineers with subject matter experts. So when I think back on the predictive policing machine learning algorithm I developed, when I first started, I didn't really know anything about the data. So it's data from the UK, and I'm from the United States. So I took several weeks just understanding the data, visualizing the data, and so much so that I know if I ever want to go on vacation to the UK, certain months and times of year that I should avoid. So it's very important that if you don't have the subject matter knowledge of the data, to work with a SME that can help you better understand that data. And then questions you'll ask. Will protected attributes like gender, age, or ethnic background influence the output? Are seemingly harmless features like salary is it a hiding proxy for protected attributes? And so I'll talk more about this, but when you look at certain data sets, there's a high correlation between income and race. And so if you start to filter on income, inadvertently, you could be discriminating against race. So just a lot of certain things that you have to understand. And then how will you enable end users to control the use of the data about them? So when we look at regulations like the GDPR in the UK, there are requirements around data ownership that companies have to follow. And we'll talk about that. And then bias shows up in your algorithm. So this is the learning algorithm selection phase, where you have your data, and then now you have to give your data to a learning algorithm. And a lot of my experiences in just building machine learning systems, there are certain algorithms that just out of the gate perform better on a certain data set. And so you really have to experiment with the different learning algorithms to find which one gives you the best prediction power. And then, of course, testing. That seems like I shouldn't even have to say that, but once you build a system, you'll want to test it. You'll typically reserve 20 to 30% of your data for testing. I go back to that facial recognition system. Did they test it before they released it? And who did they test it on? And so questions you'll ask. Which metrics will you use to evaluate your model's performance? That's very important. And does your use case require a more interpretable algorithm? So there are some learning algorithms where you can tweak the hyperparameters to improve performance. And then bias shows up in your model. Once you have that model, you are typically going to integrate it into an existing system to add intelligence. You'll need to identify retraining to combat that drift that we talked about. And then you'll need to monitor your systems for failure and measure and report the results. So questions that you'll ask during this stage: do you have a plan to monitor your model for poor performance? Again, it seems like a common sense question to ask. And then, do you plan to store the model predictions, just in case you need to answer consumer requests? Why didn't I get this loan? And then, can a bad actor infer anything about individuals by using your system? And lastly, bias shows up in our action. So this is where we have the output of the machine learning model. So no, this person should not get a home loan. And we have to interpret the results and take action on the results. So did you notice that the automated home loan approval process typically denies certain groups? Did you notice that? And if you did, how do you give that feedback back to the development team, the engineering team, to let them know something is not quite right with the model that you're using? And so that leads into some of the risk and ethics questions. Does a human review the output? How do they give that feedback to the development team? And how does the human understand the output to be able to explain it to someone? So at a high level, there are many mitigation strategies that you can put in place. One, and I've said this 3 or 4 times, ensure your data set represents the environment where you're deploying your model. Determine if there are disallowed biases. That's that example where there's a high correlation between race and income. Explore the correlations between the features in your data set and try to untangle those. And determine the impact and decide if you're going to move forward. Now let's talk about explainable AI. Who's heard of explainable AI? It's a very important part of ethical AI, and there are several components. And it just really boils down to being able to explain why your model made a certain prediction. So first, you need to have explainable data. Someone may want to know, what data did you use to train that machine learning model and why? Explainable predictions. So what features and weights did you use when you trained that model? And lastly, what are the thresholds that you use for a prediction? Like I said before, let's say a model returns 75% confidence that the person is going to pay back the loan. Is that enough to say yes? Or does it need to be 90%? Does it need to be 95%? So when we think about explainable AI, there are checks and balances that you can incorporate at each phase. So typically you start with problem formation, and that goes back to, does it even make sense to use machine learning? Like, that's the first question you should ask. Does it make sense? And if it does, Then during your data set construction, does the data itself need to be modified to mitigate bias? And then the algorithm selection. Remember, I talked about needing to tune the hyperparameters. Can hyperparameters be tuned for accuracy? And then you have the training and the testing process. Has the model been evaluated for relevant fairness metrics? And then deployment. Once you deploy the model, is it deployed on a population it wasn't trained for? And then that ongoing monitoring and feedback. Does the model allow for feedback loops? Is there drift? And a lot of this is very manual, all those steps I just talked about. But it would be nice if we had an automated way to do this, right? Wouldn't that be nice? Well, if you use AWS, then the answer is yes. Has anyone ever played around with Amazon SageMaker? Machine learning in the cloud. It's AWS's machine learning as a service. And it was the tool that really helped jumpstart my machine learning journey. A few years ago, Amazon SageMaker introduced a tool or a component called Clarify. And it allows you to test your data and your model for bias. And it can even explain why a trained model makes certain predictions. It also produces bias and explainability reports. And it's very simple to use. And I'll give you a quick demo. But when we looked at incorporating, when we looked at this machine learning process, there are 3 places where you can incorporate SageMaker Clarify. The first is during the data set construction. There's a tool called Data Wrangler that does exactly what it says. It helps you wrangle your data and prepare it for the machine learning process. But it can also help to identify bias in your data set before you even train a model. You can also use Clarify in the training and testing process. It creates processing jobs that detect bias, and it helps you explain model predictions. And then once you have your model in production, you can use Clarify to monitor it for drift. So when we think about the features of SageMaker Clarify, there are 4 main areas. First, it can help you detect pre-training bias, and that's what I talked about, bias in your data. It can help you with post-training bias, checking the trained model, with model explainability, and also monitoring. So today we only have time to look at number 1, detecting bias during the data prep stage, but I encourage you to play around with the different features. And if you are really curious about AWS, reach out to me. I'll have credits that I can give to you so you can just go in there and play around. So like I said, we're only going to look at detecting bias. So let's talk about our example. So I mentioned to you that I developed a predictive policing machine learning model. It's a public safety engine, and it basically predicts if a stop will lead to an arrest. And so I found the data. I put the link there if you all are curious. But they have stop and search data going back for many, many, many years. And so a quick high-level look at this data. This is before I did any pre-processing, no cleaning, formatting. This is just basically the raw data. The very far left, you have the outcome. That's the target. So we're teaching the machine how to predict that value. So did a stop lead to an arrest? So it's either no action, which means no, an arrest, which means yes. And then there's a date timestamp, location, latitude and longitude, gender, age range, and ethnicity. So of these values, which ones do you think bias can creep in? And we have to be very careful. Which ones? Say that again. I can't hear you. I still can't hear you. Oh, almost all of them, yeah. Yes, 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 yes. Definitely, though, gender, age, and ethnicity, because those are considered protected attributes that you can't, at least in the US, protected attributes that you cannot discriminate. Okay. And so with SageMaker Clarify, it actually offers 8 pre-training bias metrics. So it looks at your data and it comes up with these 8 metrics. Today we're only going to cover 2. So the class and balance. So it measures if features have equal representation across your data set, which is pretty powerful. And then this DPL, difference in proportions of labels, it measures the distribution of positive outcomes. So there again, it's just helping you evaluate your data before you train. So let's have a quick demo. So here I have a Jupyter notebook, and yes, I'm a Java developer trying to write Python. So I've gone through and pre-processed the data, formatted it for the machine learning process. So I'm going to skip over all of that, and I want to get to the SageMaker Clarify section. And so this is where I'm going to use a SageMaker processing job to detect the pre-training bias. And when we think about that, all we need to do is set up 2 configurations. First, it's this data config. This is where you point it to the data. You tell it where to put the final PDF report that it's going to generate. And you tell it what we are predicting and the type of data set used. The second configuration is very simple. It's the bias detection settings. You tell it the favorable outcomes, and you define the facets, or the sensitive columns we want to monitor for bias. And that's it. You have those 2 configurations. You pass it to the Clarify processor library, and it runs. It takes several minutes, really depending on the size of your data and the type and number of processing instances you're using to run that job. It produces that report, and it stores it, in this case, in S3. And that's all it takes to generate this analysis report. So let's take a look. So when you run that Clarify job, you'll first see the data set report, several bar charts with the data distribution of the outcome, the predicted values. And if you continue to scroll down, you'll see a lot more charts and graphs about distribution, pre-training bias metrics. You'll see a pie chart. But after that, you'll see the most important part. It's those 8 metrics that I mentioned to you, and we're only going to look at 2. So the first is this class imbalance. It tells us if we have equal representation across our data set. Now, a perfectly balanced class gives a value of 0. In this case, our value is 0.557, which means the balance isn't that great. Red flag. The next is this DPL, and it measures the distribution of positive outcomes, in our case, no crime, across the different columns. In this case, the value is 0.018, and the further this value is away from 0, shows that there's more bias in your data. And so like I mentioned, there are a total of 8 metrics that really help you understand your data. But just looking at those 2, we need to do some additional work on this data set before we train a model. So a really cool tool. Like I said, if you want to check it out, just ping me on LinkedIn and I will send you AWS credits. So as we start to wrap up our time together, you may be thinking, well, Kehsa, ethical machine learning, ethical AI, it sounds nice. I sort of see the importance of it, but I'm just a developer. I just code what people tell me to code. It doesn't really matter. Well, you could be putting your company in the hot seat, especially if the company breaks the law. And then just apart from that, in this world of AI and machine learning, as developers, we now have to look at ethics, the morality, bias when we're building systems. Like, we have that responsibility. And I mentioned to you in the UK, there's the GDPR. The US has something similar. But this basically requires that you tell individuals that you have information on them and you're using it in this AI machine learning world to make decisions. And so with GDPR, the data ownership, you need to obtain permission from people in order to use their data. You need to have the right to forget. So someone can say, delete all of the data you have on me. Explainability, the right to explain. So companies must notify users how their data will be used. And I'm sure all of this is in all of that tiny fine print where you just click consent. And then AI innovation. This is saying AI can't be the sole decision maker. In the US, we have something similar. It's called the AI Bill of Rights. And it really enforces safe and effective systems, that we should be protected from that. It says we should not face discrimination by algorithms. We should be protected from abusive data practices. And we should know that an automated system is being used. And there should always be human alternatives. And now, I started talking about this already, but we all have a duty as engineers. It's no longer acceptable to just blindly implement a system because your boss told you to do it, especially those that use AI and machine learning to determine what happens next to a person. So when you implement these systems, look at it from a moral and ethical standpoint and really try to make the world a better place. Don't supercharge bias using AI. And so if you want to learn more, I have a course on LinkedIn Learning. It's an introduction to artificial intelligence and machine learning using Jupyter and Python. And just message me on LinkedIn and I will send you a free access code so you can continue your learning journey with machine learning. And there is a section in there about bias. And that is it. Thank you for your time today, and I will open the floor to questions. And what's the one takeaway? I said it like 3 or 4 times. What do you have to remember? When you deploy a machine learning system and you deploy it in a particular environment, make sure what? Make sure what? Yeah, definitely that it's tested, and that it's tested on the environment that you're going to deploy it in. We don't want cities banning facial recognition because it's not the technology that's the issue. Any questions? Okay, that means I explained everything perfectly. Sounds good. Well, thank you all. I'll be up here. If anyone has questions, they want to come chat, I'll be up here. Thank you.